defined as a shape with all equal sides and all equal angles. Okay? When we have that, it creates so many great things that you can do. You know that every angle is equal, you know that every side is equal, and you know how to break equal things into equal pieces. So today we're going to use this formula. The area of a regular polygon is equal to 1/2 the apothem times the perimeter. There's only one thing in there you're scared of and scoffing about. What is it? The apothem. Okay? So, are any issues with the perimeter? Especially the perimeter of a regular polygon. So if it has 3 sides and it gives you 1 side length, what do?
Multiply by 3.
If it has 5 sides and it gives you 1 side length, what do?
Multiply by 5.
So perimeter is not a big issue, but the apothem could cause you guys a little bit of a heartache here. So, scroll forward. So I want to kind of look at this picture right here. I don't know if I can make it any bigger. All right, so here's a square. Right, a square is a regular polygon, but I've also added a different shape.
A circle.
A circle. So we just left circles last unit, and now we're talking about area of shapes. So what do you notice about this square?
It's in the circle.
It has a right triangle.
There is a right triangle. Perfect. So a radius is defined as from the center of a shape to the outside. So now I'm telling you guys that polygons have radiuses.
Whoa.
Because the radius of this circle and the radius of this square are exactly the same thing. It goes from the center to the outside edge. Okay? The apothem is from the center of the shape perpendicular to the base. And actually said it creates a right triangle. Every radius, every apothem, and every side of a shape will create a right triangle. Cool? Something else also amazing that happens is every apothem bisects every side of a regular polygon. So these two pieces are exactly the same length. So if you have a side length, how do you find one side of your right triangle?
You divide it by 2.
Cut it in half. Right? So what we're going to do today is look at how are the angles in here created? How do we figure out what is the angle inside that right triangle?
Pythagorean.
No. So we're just going to go back to circles and central angles. So if I draw a radius here, oops, go back. If I draw a radius here, and I draw a radius here, and I draw a radius here, how many central angles are inside of that circle? 4. So if I take 360 degrees and divide it by 4, how big is each central angle?
90.
So I get all these 90-degree angles, 90, 90, 90, and 90. So an apothem bisects the side of the shape,
It also bisects the
and it bisects the angle. So so each of these are 45 degrees. So it creates, my homeboy, the 45, 45, 90 right triangle. Okay, you also know that in a square, diagonals bisect, so you could have said that was 45 by definitions of squares. So then we use this 45, 45, 90 right triangle to find the only 2 lengths that we need. 1, the apothem, and 2, maybe the length of the side. We don't really care how long the radius is. All right, so as the shapes increase in complexity, they also simplify in solving. So let's say that this square is, I'm going to give you an easy number, 6 square roots of 2. Okay, so if I was going to find, you know what, I don't want to do that. Let's say the square is 6 units long. What is the area of this square?
36. 36.
Base times height, right? Now, if I was going to use the 1/2 the apothem times the perimeter, I should get exactly the same number. The shape's not changing sizes. So if this length here is 6, how big is each of these lengths right here?
3.
How long is this piece? Because it's a 45, 45, 90, the legs are congruent. So if I do 1/2 the length of my apothem times the perimeter, 6, 12, 18, 24. What's half of 72?
36.
Same exact number. So you can use the 1/2 the apothem times the perimeter to find the area of a shape, but don't do it if you don't have to, right? If you can just use base times height, use base times height. Sometimes using the apothem creates different avenues. So we'll kind of go through this in 2 layers, right? Here is the shape. This is an equilateral triangle. Step number 1, let's find out what kind of angles are created by the apothem and the radius, right? So do you see my triangle right here? Can you see the red triangle?
Yes.
All right, so step number 1, let's kind of figure out what kind of angles are being created inside of that triangle. So I have 1, 2, 3 central angles. That is 1 radius, 2 radiuses, 3 radiuses. All the radiuses are blue. So 360 divided by 3, how big is each central angle? 120. And how big is this central angle? This one right here, the whole blue angle. 120. Alright, so if I cut 120 in half because apothems bisect central angles, how big is each angle here?
60.
90? 60?
30.
30. So now when I solve this, it's every equilateral triangle will create a 30, 60, 90 right triangle. Every single one. That's why we go through the process. Every single one is a 30, 60, 90. But realize where the 60-degree angle is and where the 30-degree angle is. So apothem, radius, and base. Does that kind of make sense? So I'm going to skip to the next one, and now we're actually going to use mathematical numbers to solve for the area of an equilateral triangle. Oh, time out real quick. How big is this angle right here?
30.
How big is this one?
30.
So it also has a 30, 60, 90 right there, which you could use to solve for just the height. The big blue line, the apothem plus the radius, the whole height. And you could do 1/2 base times height too, right? Lots of different things you could do.
But you don't have, okay.
You don't have to, but you can.
But you don't, okay. I know what I'm talking
Boom. How would you approach this problem? If I'm asking you to find the area of that equilateral triangle. Okay, that's a great way to start.
Wait, don't we know that there's the 30, 60, 90 right triangle?
So inside, you have to kind of draw, your apothem goes from the center of your shape perpendicularly down to the base. That's your apothem, your A value. That's what an apothem is, from the center of the shape perpendicular to the base. There is also a radius that goes right here. And then we talked about on the last slide, what kind of triangle is that?
30, 60, 90.
But where does the 30 go and where does the 60 go?
The 60 goes in the middle, like, yeah.
And if you forget that, you know that in an equilateral triangle, which is also equal angular, that this whole angle is 60. And you cut 60 in half and you get 30 there. So right now I know that this entire measurement is 12. How big is each piece? So if this is a 30, 60, 90 right triangle, I'll do that over here. How do you get from here to here? You divide by the square root of 3. So 6 divided by the square root of 3. Okay, and guess what? You're done. Because what do you have now?
A pop-up.
Now you have your apothem. So to calculate the area of an equilateral triangle, it is 1/2 times the apothem times the perimeter, which you have to justify yourself. So multiply all the whole numbers together. What's 1/2 times 2? 1 times 36.
36. Is it gonna tell us to leave it in?
It will say either leave it in simplest radical form or use the nearest 10. Okay?
I did it with like,
I would have done it the exact way you're about to tell me. Go ahead.
well, I just cut the triangle in half and then did 30, 60, 90 and half.
So this is 60, this is 30, and how do you get from, this is your 1 side, your 2 side, and your square root of 3. So it is 6 still, and from here to here is,
6 square roots of
this is 6 times the square root of 3 is 6 square roots of 3. So 1/2 times the base times the height. What's 1/2 times 6? 3 times 12. So just using 1/2 base times height was substantially faster. That's why geometry sucks, because either you see it or you don't. Now, do I tell you, you have to use 1/2 the apothem times your perimeter to solve for this? No, I just said find the area of the shape. Cool? Alright, let's do another shape. Hey, homeboy, the square. So, now we already talked about a square, a radius that goes from the center of the circle to the outside. So how many central angles does a square have? Are we seeing kind of a relationship? 4 sides, 4 congruent central angles. 3 sides had, so if it has 5 sides, it's going to have 5 congruent central angles. So if I have 360 degrees, and I divide that into 4 equal pieces, that is also just a property of diagonals in a square. All squares bisect at a perpendicular angle. So, if this is 90 degrees and I cut it in half, how big is each angle? 45. It also creates a 45, 45, 90 triangle right here that you could also maybe use to drive. Alright? So every square will have a 45, 45, 90 with the apothem and the radius. Let's try it.
What, question. Where it says regular quadrilateral?
So a regular quadrilateral, there is only one regular quadrilateral square. A rhombus is not a regular quadrilateral. Yeah, it's a square.
And the line on the top.
Square. I mean, I'm just kind of filling in numbers. Really, it's just there so you don't have to redraw the shape yourself. There will be a question just like that, which is fill in the angle measurements on your quiz. So hopefully we're okay with that. So here we go. How would you do this one? Let's do it my way first, then we'll do it your way. So we've already discussed every square or regular quadrilateral will create what kind of triangle with the apothem and the radius?
45, 45, 90.
So this is a 45, 45, 90 right triangle. How do you get from the hypotenuse to the leg on a 45, 45, 90?
Pi by the square root.
Three square roots of 2. Because remember, 3 times 2 is 6. Alright, so we have already solved our apothem is 3 square roots of 2. How long is this piece? So how long is this piece? Which means that the whole side length is So now I have enough information to do my apothem, my perimeter divided by 2, or 1/2 the apothem times the perimeter. 1/2 times my apothem times my perimeter. 6, 6, 6, and 6 is 24. So 1/2 times 24, 12. 12 times 3, 36. That's all my whole numbers. 2 times 2. What is the square root of 4?
2.
So this is really
36 times 2.
centimeters
Square.
squared.
Aha.
Alright, so now I think really the issue is working with radicals, not necessarily understanding the formula. Right? Go ahead, Miles.
Oh, I just did base times height.
So how did you get there? Because not everybody sees it.
Oh, I just did the same thing you did, and then when I got the length of the whole
Oh, when you got here?
Yeah.
You just did 6 square root of 2 times 6 square root of 2, which is 36 square root of 4, which is 36 times 2, which is 72. I would have probably done this. And then 12 divided by the square root of 2 is 6 square roots of 2. And it would have given me one side using the diagonal. Right, now this is the last shape where you get an easy freebie. It's the last one.
Oh, hey friend.
Because what's the next shape? After 4 comes
Pentagon.
5.
Pentagon.
Hey buddy. Hey friend. This is the absolute worst shape. And why are we doing this?
Because you love us.
No.
It's going to be on our quiz.
No.
Because it's on the fine.
No. Because we're only working in 2 dimensions right now. When I give you guys a pentagonal prism,
That's
aka a septahedron,
Whoa.
and I ask you to find the total surface area of that pentagonal prism, you have to find the area of the base. And what shape is the base? A pentagon. Then you have to find the area of the base, you have to find the area of the other base, you have to find the area of the lateral faces, and add them all together. So if you can't find the area of a pentagon, screwed.
Darn.
I might be nice and give you the apothem and the perimeter when it comes to those shapes, because I'm really interested in the surface area, not can you find the area of a regular polygon. You know, when it gets to volume, it's the area of the base times the height. You have to be able to find the area of a pentagonal shape. All right, so same logic here. If it has 5 sides, how many congruent central angles? So 360 divided by 5. 360 divided by 5 congruent central angles. 72. You want to stick with that?
No. Wait.
Yeah.
Do it on paper.
Yeah.
I'm smart.
Sure.
Don't question.
Sure. Okay. So if I cut 72 in half, how big?
36.
36.
Wait a second.
What? So now I have a triangle right here that has a 90-degree angle, a 36-degree angle, and a 54. Yes. 2 ways you can justify that. Remember way back in the day when we found the interior angle sum of polygons?
What?
And it said this shape has 5 sides. So 3 times 180 divided by 5 is, I know that this angle, this one interior angle of a regular pentagon is 108. So 108 divided by 2 is 54. Justified. Now, what's that? So this whole angle from here to here is 108 degrees. And you can cut that in half to find 54 and 54. Or you can use my method by using the central angle to drive the other angles. Now, there's special right triangle tricks for a 36, 54, 90 right triangle?
No.
No. No. trigonometry.
Oh,
Sine, cosine, tangent, baby.
you get so happy. when-
Because you guys always forget.
Um,
Let's do this. Hey, 5. Find the area of that shape.
huh, well, perimeter is 25.
So that is great, right? Perimeter equals 25. At minimum, you know that the perimeter must be bigger than 20. No?
Wait.
It's a multiple choice test. The area.
Oh,
Oh.
Throw it out there. I don't know. So here's your apothem. You can kind of just throw wherever you want. Right here. Here's your radius. And what do we talk about for that radius and that apothem? They create a 36, 54, 90 right triangle. So if one side length is 5, that means that each piece is 2.5.
Oh, so it's cosine. Right?
So you're really looking for the apothem right here. You can only use tangent. And you make sure your calculator's in degrees when you do it. The tangent of 54 degrees is equal to the opposite length over .54. Somebody math that for me.
I did it wrong.
3.4.
Is that an A or a 9?
It's an A
Oh. I was like, why did we have
because it's
an
the
A?
apothem. So here's the good thing about the only good thing about this is once you solve for it, you get a decimal, and the rest of your problem's in decimals. So you don't have to worry about radicals anymore. So our apothem is 3.4. So now it's 1/2 the apothem times the perimeter. It's, I can't do that.
42.5.
42.5.
If you use the actual decimal, it's like 42.
Did we use the actual
So yeah, when you because it's 3.44, and 3.44 compounded 25 times will kind of increase it a little bit.
Oh, no, I did. So wait, what'd you?
I just use 3.4 for simplicity to kind of help grasp any small recollection or of effort you guys have left. Facts, right? And some of you guys got beat over the head with this today. It's a monster. It's not hard. It's just very tedious. There's also a triangle in here that you could do 1/2 the base times the height and then multiply that by 5 because there's 5 triangles in there.
Oh, I like that.
But you only know this number. Once you solve for this number, then you could do 1/2 base times height, but it's almost easier just to use that one. With my homeboy, this one's close to my heart. Hexagon.
Oh, it's on your arm.
Yeah, it's all over me. So 6 sides, which means 6 congruent angles.
They're equilateral.
So, and hey, guess what? They're also all equilateral triangles. And you already know how to find the area of one equilateral triangle. But if you cut this 60-degree angle in half, what happens? It gives you a different version of a 30-60 angle. A different version. Here's why these are so great. Lots of different ways to cheat on this question. If you know that this length is 14, and I don't like this question, I'm going to try. Oh. Can I do this? Can I do that? Most of you guys like seeing a base flat like that instead of crooked. You can also just turn your paper because you have manipulatives that'll do that. So when you drop your apothem down, but if you know that it's an equilateral triangle, how big is this radius?
Oh.
7.
Wait. Oh, okay, got it.
It creates that equilateral triangle because all these central angles are 60 degrees, so it's a 60, 60, 60 triangle. So it does create a 30, 60, 90, and a 30, 60, 90, which is 60, 60, 60. So you know that this length right here is the same length as each radius. The only good thing about that is, what's the easiest way to solve for an apothem? Probably for you guys, a squared plus b squared equals c squared. But for me, I know that this is 6 of one, half dozen of another, whatever you're more comfortable with. So once you have the apothem, I'm trying to math in my head real quick. 14, 28, 42. So it's 1/2 times 7 squared roots of 3 times 84.
How?
300.
Do you want to leave it in radians?
We're not even talking about radians right
I
now.
mean,
Say it right.
the squared thing.
Nope, the squared thing.
Radical.
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 Yeah, what's the radical answer?
Well,
294 squared.
294 square roots of 3.
Miles got it. Good job, Miles.
Units squared, feet squared. What's the decimal answer? 294 square roots of 3 as a decimal.
509.2229.
509. 509. This is fun, right?
No.
Dahlia's upset.
She shook. All right. What about this? What about this regular decagon?
Why?
Why not? It's not that bad. 10 sides, 10 congruent central angles.
36.
Everyone is 36. 36. So when you cut 36 in half, how big is this angle right here?
30.
It's not.
No.
It's a dodecagon.
That's a Dodecagon. No.
18.
My bad. A dodecagon, that was good practice, has 12 sides.
Yeah.
Yikes.
So they're
And if you forgot, you could have counted 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So let's do 360 divided by 12, 30. So that creates 30, 30, 30.
So it's 15.
So in this apothem radius, it has a 15-degree angle on the next to the middle in the center, and a 75-degree angle on the side, which creates your homeboy the 15, 75, 90 special right triangle, which tells you you're going to have to do trig.
Wait,
So dodecahedrons create 14, or sorry, dodecagons create 14 ahedrons. So if I asked you to find the volume of a 14-ahedron, or maybe the 13-ahedron, you'd have to be able to use the dodecagon to drive that process.
This is not my homework.
Rolling with the wrong crew, bro. So, look at these are on your paper, right?
One of them. The
Or not.
nonagon is. Nonagon.
Is this information on there?
No, nonagon, not the decagon.
Okay, so in this scenario, it's 1/2 times the apothem times the perimeter.
So times it by 9.
I do this because this is the perimeter. 9 sides that are 9.6 long. That's child's play for you guys because it's already there. It's plug and chug formula, right? 1/2 times the apothem times the perimeter. How many decagon has how many sides?
10. Oh, 10. Yeah, 10.
So I had this great but I feel like that these three shapes will get the job done. Is that a good compromise?
Yeah.
So I want these three shapes for you guys to practice, just three of them, and that'll kind of get you prepared enough if you have notes. I'm not going to hand you this. Now, if you want this, you can take it. I'm not going to tell you you can't have it. That's up here on the table. If you want it, you can take it. That is kind of our assignment for today. If you went through that, you would probably be more prepared for your quiz. But what I've done has equally prepared you for your quiz. So I'm not grading that. It's just straight up. That's just straight up practice. Take it if you want it. Leave it if you want to.
If I take it, I know I'm not.
I got it.